Like, and they have all these update texture regions and stuff like that. Let's see. And I'm looking at this forum post, basically. There's like get pixel formats or like PF A32B, 32G, 32F. I'm not really seeing anything that's... Well, let's see if there's any sort of source.init. Let's just look in the entire code base, because I'm not seeing, you know, anything that actually using this online real quick. So maybe we can, you know, roll through some of the rest of the code base and see if anywhere else it actually uses something. So look, it's... So what is this? This is texture render target cube. So the texture format could either be RGBAF 16F or BGRA. So let's see, if this is a float format, it's a float 16 color, and it's mem copying out of float 16 color. So it's either TC default or TC HDR. Otherwise, it's using an F color out of this thing. So what's the difference between these HDR textures and the non-HDR textures? Alright, you may have read there are several things you might do to provide great HDR experience. Like, what the fuck does just HDR stand for? High density resolution or something? Like, I mean, let's just Google, what does HDR stand for? High dynamic range, and refers to a scene that includes both bright and dark elements. And I don't think that makes sense. Alright, I guess it's high dynamic range rendering. In standard rendering, the red, green, and blue values for a pixel are represented by a fraction in the range 0 to 1, where 0 represents 0 and 1 represents the maximum. That doesn't accurately reflect the way lighting works in real life. The human eye tends to adjust to local lighting conditions. So, allowing the internal representation of graphics to use values outside of the 0 to 1 range is the essence of high dynamic range rendering. HDR is active. The scene is rendered into an HDR image buffer which can accommodate pixel values outside of 0 to 1. This buffer is then post-processed using image effects. Advantages of HDR colors not being lost in high intensity areas. Well, yeah. Using floating point render textures renders slower, requires more VRAM. No hardware anti-aliasing support for some of these things. Not supported on all hardware. Well, if I've got vector stuff, right? Like, I don't want to go from 0 to 1. I want to go from like -1 to 1 for values. That sort of stuff. So I'm gonna have to think about Let's take a look at some texture stuff. Like, let's just go make a texture. Let's make a super awesome, amazing texture of awesomeness. Let's actually turn this into a texture. How about that? Let's import it and then mess around with it as it. Look at some constraints. So let's save this. Alright, let's say the compression settings of this are default. So this is an 800 by 600 texture. Let's change this to 1024. Yeah, that's not. Alright, so what is the size of a displacement map? 2 megs? What is HDR? 4 megs. Let's see, HDR compressed, 4 megs. And this has alpha. Alright, so it'd be like 4 megs for the resource size versus 234K. Ugh. Alright, so the difference is going to be a massive amount of memory for using like HDR textures. We want RGBA 8 is what it looks like. The vector displacement map. Alright, so if we have a texture sample that takes this texture in, let's put it as vector displacement and let's see what it expects of us for the definition of this thing. So this is going to take in a linear color. So what exactly does a linear color mean? I want to know a specific definition of a linear color. Like what values can I get out of a linear color? What is the general speaking a good rule of thumb to keep in mind when creating diffuse albedo textures? Like just what is a linear color? Just an F linear color is a 32-bit component floating point RGBA color. Well, I get that, but I don't know if the sample type actually gives me what numbers I can use with this. Alright, so I mean, I need to know exactly the definition of these things, and I don't know them. I'm not a graphics programmer, so it's probably some people already know all the information. Oh, you know, just it's obvious. Linear color means this. It's like, well, it's all garbage. Yeah, the type of data. Well, I want to know what the sampler type can be. The type of data. Yes, we understand the type of data. The green channel. Yes, I understand it's the green channel, but what values can come out of the green channel? This is what's important. I wanted to say the value of the green for a linear color will be between 0 and 1. I want it to just tell me that. Alright, what are the value ranges for linear color Unreal? No, this isn't, none of this is right. Let's see. Store vector direction in texture Unreal. Get texture direction. The texture gonna be where the text is pointing up no matter what. Wow. Read direction information from texture Unreal. So yeah, this might be a little boring while I try to figure out where information is, but I gotta do it. I gotta figure it out. Let's see, value range for HDR texture Unreal. What is the dynamic range in Unreal? That's not helpful at all. Urgh. Yeah, the thing that normal maps work and all that stuff because they're normal to the surface and you already know which kind of direction you're going, so you're not like the normal doesn't have any negative values, but with this flow field stuff, we do have negative values. So for me to store things as colors, I need negative colors in the engine for it to work, or I need to split it apart and have, you know, 0 to, I need to myself create the concept of a negative color by splitting the color space in half and saying anything above this value is something else. I'm just not finding the information I want. I'm kind of surprised that, like, I need a data sheet, you know, like technical, you know, what is the literal technical definition of a linear color? Like, what exactly it is, you know, is it? And I know they're hiding all that stuff from me. I guess it's just 0 to 1. Like, that's all we're gonna get. Hmm. Well, do displacement maps have negative information? can take red and green channels from your normal, which make up your height info, and add them together to get a height map. Use your displacement map to alert between your low and high values. Yeah. Okay, so basically, the information that I'm getting is it's simple. It's always from 0 to 1. We can get more values out of it using like an HDR texture, but this is not really what you're supposed to use it for. So I need to store everything as... I need to store everything in a texture in kind of a compressed format that I can read out. And I need to store everything inside of the data in the game just in the pre-computed form. So everything in the game needs to be stored as raw data, and everything is stored in the texture is in this like compressed format. Alright. Yeah, how dare I work? How dare I? I'm sadly attempting to actually be successful in making this game. I know if I want to be a pro elite Twitch streamer, I'm gonna have to abandon my dreams. Okay, so we've answered our question. Our question was, what does everything get stored as? The answer to that is it gets stored as garbage, and there's nothing we can do about it except deal with garbage. Well, then we're just gonna have to deal with garbage. Damn. Alright. So I should just deal with this color crap. Like that's just reality. That's what it seems like. We could store more information in here. We could even store, yeah, but we probably shouldn't. We probably should just store what we need. So we're going to have to think about this. Well, it seems like we'll just have the texture data be different. You're trying to find the Steam Dev App ID variable, but it won't show? Well, Chris Goku 2, I have not done Steam integration. Could you give me, like, if I'm gonna take a look at this and maybe see if I can help you out. I'm kind of interested because I'm eventually gonna have to do Steam integration for this thing. Where are you trying to find this variable? Is this in Unreal, or is this inside of Steam in some developer tool where you have an account and you have like a game that's registered and you're trying to find where the damn dev app ID is? Or the variable that if you're in code, Like, should I just search the code base for Steam Dev App ID? Looks like there's an online subsystem Steam that's something you can enable. The Dev App ID is 480. Let's see, it's something inside of Steam Dev App ID, which is getInt inside of global config. Yeah, so it looks like it's inside of the config. It's not an actual variable. It's just like something stored inside of the config system itself. So if you're trying to fetch that at runtime, you're going to want to call gconfig getInt and all that sort of stuff. Like it's not a, yeah, it's not like a fully qualified variable. So yeah, what you're going to want to do is, how did I get to here? The online subsystem steam.cpp. Oh, I just did a full search on the entire code base for Unreal and pulled it up. With just, there's only 4 places in the entire code base where it even references this variable, so that's usually my best tool for finding crap. So yeah, it's just gconfig getInt, just like that, and you should be able to snag it. Are you trying to get it from blueprints, or are you in C++ land? The Solution Explorer doesn't work? You know, I've never used the Solution Explorer for anything other than just like double clicking on files. So, oh, is there like some sort of find function here? Is that what you're using? Yeah, it's not finding much, is it? Search within file content, search within external items. Yeah, I don't know. Yeah, it kind of would give you, you know, if it's saying search within file contents or search within external items, then I don't know. It appears. How did I use this? The full search? I just hit Control Shift F, and it pulls this up. It's just the find function. So Control Shift F, it should boot up the find and replace, and all that. So I use that all the time. So I don't know. How do you access the config from? Is there some sort of like get bool or something inside of Blueprint land that you can use? I mean, I made my own config system, so like I don't see anything in Blueprint land to actually snag that. Yeah, you can set it in the INI file and all that stuff. I was just wondering if you could read it at runtime or anything, but I guess you don't really need to. The online subsystem will pull it out, and you don't really have to worry about it. Interesting. I really don't know much about the Steam integration for Unreal, so in fact, my experience with it is absolutely nothing. Oh yeah, no problem, Chris Goku. I'm working on my own game, but game development's not the easiest thing in the world, so anytime I can help somebody, I try to. on the API page. It's easy. Yeah, I figured it's not too hard, especially if you're not trying to use a whole bunch of complicated features. And especially like if they already have an online subsystem class and all that stuff, then we don't have to do too much. Just couldn't find the variable? Yeah. Sometimes it's the simplest things that, you know, that are the most difficult. Also, thank you for following. I'm here way too often working on stuff. Okay, so I was working on this flow field crap, and I was thinking about how I'm going to actually store this information. So I'm going to need the T-array of F colors for the actual information. I'm also going to need a T-array of F vector 4s, and do I need to save them as F vector 4s? I probably should, just because I might need that extra channel, and if I need to compress the data or something, I can do it later. Alright, so that's going to be inside of the flow field stuff itself, which is in our map utils. So right now I've got these path colors and all this stuff. So I think I'm going to have to edit all this and kind of copy it out. And what I'll plan to do is make all this code non-experimental code when I'm finished. So let's do path data, particle data, and flow data. So let's get all our stuff reset when we actually call reset. Alright, so when we set up for the map, we're going to init all these things. So it'll be F vector 4, 0 vector, none. Do that for all 4 of these things. What am I making? That is a good question. I'm working on a game called Dashkin with Adam Phillips, who's my partner in crime. I'm the engineer, he's the artist. We're working on a... You might remember if you were on the internet in 2006, Newgrounds and all that. Adam Phillips is the person who made Bitey of Brackenwood and continues to make all the Brackenwood stuff. So we're making a game in Unreal 4 for that, in that universe with Bitey and all that. It's a platformer. Right now we're working on the visual look of the game, but you'll be running around and doing all sorts of stuff like that. And right now this is all just like garbage placeholder assets that I made, so they look like trash. If you want to see cool stuff, you can check out what Adam does on his streams. But I'm just messing around. I make like the nuts and bolts stuff. So like this is a good example is like this is a waterfall that I made, and I just made it so you can like change all the stuff about the waterfall and everything like that, and then he can go actually, like, these are just garbage textures I threw in there, so he can do like actual textures and add particle effects and whatever the hell else he wants. So right now we're working on the fluid stuff. So like an example here is I've been creating kind of a flow field particle simulation thing in order to figure out like where water would go. It's like this, we have this, we spawn water here, and so when we're in our material, we'll reference all these textures. This is like the distance from shore for like shore ripples. Then we've got like our height map and normal maps about like how far below the surface stuff is, so we can figure out, anything with depth. And then the flow field stuff for like motion on our textures and everything is what we'll be figuring out. So gathering the data, we've worked on this for a while, and I will continue to work on it. It's all like statically generating this sort of stuff so that at runtime we can just kind of look it up. Is there no zero vector? F vector 4 has no member zero vector. Really? Yeah, and if you're ever wanting to check out Adam's stuff, who's the other guy working on the project, he streams on the weekends. And he does like all the animation and art and cool stuff. Well, I guess it just initializes to zero vector, so I can just slap this in here, just like that, and be good enough. Alright, so we're going to want to change this right particles to not just take the T-ray of F colors, but also take a T-ray of F vector 4 references. So we'll change this to out colors and out data. Yeah, Adam's a lot more popular than I am because I stream like programming stuff that's all boring and stupid, and he streams like art stuff, which is usually interesting and fun. So we're going to have our particle data. So our T-ray of F vector 4, out data, out colors. Usually, yeah. You never know. What kind of game are you working on? Anything interesting that you'd like to share? Because there have been a few people who've been on Twitch working on, like one guy was working on a horror game. Another guy was working on a mobile kind of... God, what was it yesterday? It's like a mobile adventure game. It looked pretty cool. So let's see, we are writing fill color. Alright, so let's do our F vector core reference here. Data equals out data sub 32 index equals get index. Part didn't pause. Compiler will optimize this crap so I don't have to worry about it. Alright, so we'll have our data this is an F vector 4, so fill color should take the color and the actual F vector 4 reference data. Alright, so I need to figure out what I actually want this stuff to even look like, don't I? Well, I want the direction to be like this thing. So I guess, yeah, we'll just say like, oh, you know, just a third-person shooter, nothing complex. There's plenty of complex things about making a third-person shooter. Alright, data equals, is there a reset function or just like set to nothing? Fine, we'll just say, we'll just clear it. So data.x equals dir.x, data.y equals dir.y, data.z equals dir.z. Can we just say data equals dir? Does that actually work? Nah, it's gonna get pissed off at that. Oh man, so this direction is in, it looks like it's in texture space, and the direction that we need is in world space. So we need to figure out what the transform between texture space and world space is going to be here. A lot of thought in stage design. Alright, that sounds pretty cool. You can do a lot of stuff with gravity and physics based. Fun times. There's a lot of interesting games. So, okay, we have the X and the Y for the actual particle. We have the position history. Did we actually make the functions that I need earlier? Let's see. Yeah, we have get world position for grid. Did we actually fill it up? We did. Get world position for grid. Okay, so what I want is the direction is going to be the direction in. Yeah, this whole thing needs to be changed. The direction here needs to F vector actual position is going to be, we're on the particles, so we flow field get world position for grid, and we're going to do pos.x, pos.y. And this will be fmath floor to int, both of those things. Okay, so direction is going to be an vector vector. Alright, what is impos? Alright, we're gonna have historical pause vector my position. So we need the impos.x and impos.y here. Then we'll get that working. So this is going to be my position minus historical pause. There plus equals that. The noise plus equal the size of the vector. So max. It seems very complex to learn on your own, but easy in a class session. Yeah, I think there's one of those things. You go watch like some tutorial videos or something, and you're like, oh yeah, you know, I understand what's going on. This is easy. And then you go implement it in your stuff, and you're like, the only water I can have is a square fountain in the middle of like an atrium, and woe to you if you want to have it be lit properly or have shadows work or any of that sort of stuff. So I was looking up different things, like, and a lot of the water materials and the rest that they have requires, like, they have extra cool things in there, right? Like, they'll use tessellation and all these other things to get their water to look like super awesome. And you're also like, well, that doesn't work on all hardware. You know, like, I guess you're supporting Windows only, or, you know, DirectX 11 and all that. So it's an entire other thing when you're trying to actually get it out there in a way that works. And I haven't done any water stuff either, so I'm just kind of figuring it out. You can tell because I've got all these like ridiculous cave drawings I've been working on and figuring out how exactly I'm going to be doing stuff. So it's been a process. Okay, so we've got our direction. We're going to normalize it, and we're going to do data. Let's see, can we just set it equal? We can, because it's now an F vector thing. So my position, all that. Yeah, it was one of the first things I noticed is every single like Unreal Material tutorial for water was like a square. And then I was like, yeah, that's because detecting the shore is absolutely trivial when your thing is a square. Yeah, ripples and all that stuff. I mean, all that's... A lot of it's just kind of, you know, you got a whole bunch of data and you just kind of fuzz it up and do all that sort of stuff. Have a bunch of noise textures and just move them around and, you know, add all the math together to get waves. And what I'm trying to do is get real information. So it's not like somebody has to go draw and tweak a whole lake or something. They can just place these inflows and outflows and then run like a little simulator, and then it'll fill out this information so that, you know, if we had like, you know, a little thing floating along, it would actually like fall off a waterfall and then fall off the next waterfall, and you wouldn't have to have a designer like put in a whole bunch of garbage to make that happen. It just like, you just run the simulator a little bit, and then that sort of little interaction happens. At least that's the plan. When we're finished, we can scare a whole bunch of woodland critters off into the water and then watch them fall off the waterfall and die. That's what I want to see. The simulator is easy. Well, it's an easy concept, but actually getting all like the nuts and bolts, we've run into a lot of playing with UVs. You're like, no. I mean, UVs I think is a simpler concept than all the simulation stuff. Like UVs are just texture coordinates. That's just where in a texture you're grabbing the pixel color, right? That's That's nothing. So maybe you just haven't messed around enough with those UVs. I think you'd find it pretty intuitive if you knuckle down and mess with it. But then again, I don't know. Everybody has different things. Yeah, that's kind of how this thing goes. Is I can just tick this thing along. And we just see all of our particles do their thing. And we're using like some geometry over here for this thing. Is actually this box, which is why it's all getting stopped there. And we've got a whole bunch of like pathfinding stuff, so I can do all the inflows and outflows. Yeah, the big things that we're running into was actually like saving the statically computed data. Like you can't just store that because you need it. You need to actually make a texture in order to reference it in the material, and then you need to save that texture somewhere, and it needs to be like statically created, right? You can't just like create that at runtime because it's too heavy of a computation. So it's been all that sort of stuff that's been a real pain in the ass. Not necessarily the concept behind it. Alright, so we got a direction. Alright, so this will be the direction of our water. That's fine. So we want data.w to be the noise, I guess? Max noise. We want noise divided by max noise. Alright, it's going to save the data from this particle. Use the sync load process. The synchronous loading process. I mean, there's async, there's asset loading and everything else, right? That's not a problem. It's more of actually saving a U asset from blueprint land, like actually having a blueprint go create an asset. Like you have to have an asset factory, you have to have that data and then store it and all that, and figuring out that you actually had to do that. You couldn't just like shove it all into the blueprint object in the world and have it work properly. Especially with something like a texture, right? You don't want to just like make that at runtime. You actually want to save that out as a U asset. So it's more figuring out that I had to do all that because I'm not super Unreal man. Alright, so we're going to want to save the... This is just the particle information. So this will be fine for now. So we should be able to save this out and then load it back in, and we should be good to go. Okay, that's fine. Let's make sure it actually works. Take a draw, fill color with particles. We're going to want to make these other functions that we can actually go snag information off of. Alright, this should work. Yeah, I'm not sure what you're referring to really. The U asset stuff is like if you have, you know, a 512 by 512 texture, you need to actually save that out as a texture on disk, and you can't just, there's no like, you know, save texture, you know, texture.save sort of thing. You have to, especially the texture you created, you have to actually, you know, use the texture asset factory and then create that inside of a package and save that, and it needs to be level specific and all that. So you had to, you know, then you have to get the name of the level that you're in, you need to get the path for the level, and then make, you know, the folder in there and all that. So it's not as straightforward as like, you know, my blueprint.save this thing. At least it wasn't that straightforward for me. Alright, so we need filled data with paths, and same thing with all this. So this will not be f colors, these will be f vector 4s. So we'll go ahead and implement these 4 functions so we can snag all of our information. Yeah, there's actually one guy who had run into this problem where he was trying to save some statically computed data. I think it was for like some AI he was working on, and he couldn't find any way to do it, so he was interested when I was messing around with that. Let's see, output equals, this is flow data, go with paths, so path data. This is particle data. This is flow data. Oops. Alright, so we're writing all that. Let's see, we want to write our other data as well. You would look into the packaging process. Yeah, well, I already solved all that. Like, it works, and works real well. So just writing out U assets and using